This will be the video for 5.5, the Earth's motions, and this is for your guided notes. Alright, so what is a year? Well, we know what a year is. I mean, we're pretty used to it. It's the Earth revolving around the sun. One complete revolution is called an Earth year, or just a year. It's about 365.25 days. That's why we have leap year every 4 years. We have to make up for the 0.25. So what is a day? Well, the Earth rotates or spins on its axis. The sun returning to the same point in the sky is one solar day. It actually takes about 23 hours and 56 minutes if you look at it from the side, which is called a sidereal day. So 24 hours if you're on the planet, and a little bit less if you're looking at it from the side. So there are two different ways that we can measure it. A solar day is 24 hours. A sidereal day is one complete rotation, but it takes into account the fact that the Earth is also going around the sun. So we lose about 4 minutes. And that 4-minute difference is because it takes 4 more minutes for the sun to return to the same spot on a solar day, and 4 fewer minutes on a sidereal day. And that's why we see different stars during different seasons, because we can actually see into the night sky in a different piece of the sky. And if you look at the picture, it kind of helps that make sense. So what causes the seasons? Well, the Earth's tilt on its axis as it revolves around the sun is the reason we have seasons. It's not because of the distance. It's actually the exact opposite of what you would think. The Earth is a little closer to the sun in January, and it's further from the sun in July. But that's not why we get the difference in seasons. It's because of the angle of the tilt. As the Earth moves, its axis always points in the same direction in space. So you can see that in that top picture. You can see the little red axis going through. Seasons are patterns of temperature changes and other weather trends over the course of a year. Near the equator, temperatures are nearly the same year-round because they're pointing towards the sun pretty much the same way. Near the poles, so the North and South Pole, the temperature can change drastically throughout the year. During the summer, they get nearly 24-hour-long days, and during the winter, nearly 24-hour-long nights. So the patterns are due to the changing amounts of sunlight during the year. So if you look at the top pictures, you'll see that an area on the surface within the light beam receives less energy when the surface is more tilted relative to the beam. So there's a vertical surface, and you get a nice round but very strong, concentration of light. And then when you tilt it, you expand where the light hits, but it's not as strong. So you can see that on the diagram below, where the sun is hitting directly on, near the equator at the Tropic of Cancer, and it's hitting more indirectly up at the top. So it gets a lot less energy. So up towards the equator, the sunlight is more spread out, and it's less spread out near the equator. So that you can see in that top picture, you get less energy away from the equator and more energy near the equator. So regions near the poles receive less energy than regions near the equator due to the curved surface. Earth is colder at the poles and warmer at the equator. Because the surface is curved, different parts of the Earth's surface receive different amounts of the sun's energy, and you can see that from that picture. How do the changing amounts of sunlight affect temperature changes? Well, as the Earth travels around the sun, the area of sunlight in each hemisphere changes, and you can see that in the bottom image. At an equinox, which is in September and in March, the sunlight shines equally on the northern and southern hemispheres. It's hitting right at the equator. At a solstice, the area of sunlight is at a maximum in one hemisphere and a minimum in the other. The December solstice means that we have the least amount of energy because we're in the northern hemisphere. And during the June solstice, we get the most amount of energy we will get. Characteristics of an equinox? Well, there are 2 equinoxes throughout the year, one on March 21st and one on September 21st. The sun shines equally on both hemispheres. Earth's rotation axis is leaning along Earth's orbit, neither toward or away from the sun. So it is hitting right at the equator. The strongest sunlight would be right on the equator, and then it would become a little bit weaker as you got further from the equator, but it's hitting right on. Now, a solstice is different. There are two solstices throughout the year. One is on December 21st, and one is on June 21st. The summer solstice is when the North Pole is leaning toward the sun, and that's what you can see in this picture. You'll see that it's getting some sunlight, and it's hitting north of the equator. So less than half of the southern hemisphere is in sunlight. The strongest sunlight is north of the equator. The other solstice would be December 21st, the winter solstice, and that is when the Earth is tilted the other direction. Well, and it's not because it changes its tilt, it's just that we're on the other side of the sun, so we're in a different part of our revolution. The North Pole is now leaning away from the sun, so it gets essentially no sunlight. Less than half of the northern hemisphere is in sunlight. The strongest sunlight is south of the equator. So what we see here in Minnesota is during the winter, we get really short days in December, and we get long days in June. Our longest day is in June on the 21st, and our shortest day is December 21st. And that is the last slide. So some things to remember. What causes a day? What is a day? What is a year? What is a solstice? What is an equinox? And what causes the seasons?